Hey guys, welcome to my channel, Math for Teens. In today's video, we're going to be doing a standard calculus optimization problem, where we try to find the point that minimizes the distance between itself and a point on a given function. So without further ado, let's get started. Okay, so welcome to the function we're working with. So we have x squared plus 2y squared equals 25. And I'm looking for the point along this function that minimizes the distance between itself and the point 2, 1. So whatever this distance is, I want to minimize it and find the point that minimizes it. Okay, so this is a calculus optimization problem, so how should we approach this? Well, the first thing to do, let's just define, what exactly we're dealing with. So I have a point x1, y1, which is I have a point. And I'm looking for the distance between itself and the point 2, 1. So how do I find the distance between the points? Well, this just goes back to the Pythagorean theorem. So basically, any 2 points can make a right triangle together. So the distance between the 2 points is what is the hypotenuse of this triangle. And what are these side lengths, you may ask yourself? Well, this distance is the horizontal distance between my 2 points. So if my second point is 2, 1, let's say that this is xy and this is 2, 1. What will this horizontal distance be? Well, it will be x minus 2, right? And the vertical distance will be y minus 1. And so using the Pythagorean theorem, I have that, maybe I'll write down here, t squared is equal to x minus 2 squared plus y minus 1 squared. And the last thing we need to set up before actually beginning to differentiate is, sorry, kind of sick, we are dealing with 2 different variables in this function, but they're actually linked. And because they're linked, that makes it so much easier to differentiate if we can just express y or x as a function of the other variable. And the relationship between x and y is just the function itself. We have, I guess technically it's not a function, but we have x squared plus 2y squared equals 25. And so if I'm going to choose to express x as a function of y, simply because I don't feel like dealing with this 2 over there. So what do I have? I have x squared is equal to 25 minus 2y squared. And so I have x is equal to the positive or negative square root of 25 minus 2y squared. And this technically it's 2 different values, or 2 different x values that could satisfy the minimum distance requirement. And that's because ellipses are symmetrical, right? So this actually makes total sense. I did just say that there were 2 different x values, but the thing is, on our ellipse, the point where our origin point that we're measuring distance from is kind of offset, right? It's 2, 1, so it's in the first quadrant. And so even though there would normally be 2 x values that are the same distance, for example, from the origin, and this is not the case, right? The origin is kind of offset in the first quadrant. So you will still have 2 different x values. One, which will make your derivative equal to 0. You can test the distances for each, and you'll find that one will maximize the distance, so furthest distance, versus the other will minimize it. And obviously, just by logic, the x value that's in the same quadrant as our point will be the one of smaller distance, so that will be the positive x value. And that's the reason that it's not this sort of problem where it's like, oh, I can just use either of the x points. Well, it's because symmetry was broken, right? The point we're referring to leans closer to one side than the other. Now, one final note on symmetry, just so you guys really understand, because I actually find this pretty interesting and I think will help anyone who's going to be doing problems with ellipses, for example. Sorry, let me get this down. Okay, so when is our point going to give us symmetry or not, right? When will both x values be valid for our smallest distance and not? Well, let me flip this camera. Sorry for the filming right now, by the way, but basically, if you choose a point that's in the origin, obviously the distance will be symmetrical for different x values, and it will be symmetrical here as well, right? It will be symmetrical along the x and the y. We'll have 4 different points basically that have the same distance. Versus if you choose a point that lies on the axis, right? The x or the y axis, like here, it will still have the same distance here and here. What will be broken is your vertical distance. This will, of course, be longer because this is offset upwards. Now, what if I choose a point that lies on the x-axis, like here? Well, where will it be symmetrical? Obviously, it will not be symmetrical like this. That's clearly not the case. Where it will be symmetrical is along your horizontal reflection along the y-axis. The x-axis. These two distances will be the same. So when you choose a point that lies on the x-axis, it will be symmetrical, with a horizontal reflection, and if you choose a point on the y-axis, it will be symmetrical along a vertical reflection. Yeah, so hopefully that makes some sense for you guys. Okay, so now that I have x as a function of y, I can simply sub that into my distance function. So I get d squared is equal to, instead of writing x, I'm just going to keep the positive square root and remember that at the ends, I do have a negative value that will give me the same distance, but either way, it'll just be negative for the positive value. So I'll just find the positive value and then I'll deal with the negative later. So I have the square root of 25 minus 2y squared minus 2, all of this squared, plus y minus 1 squared. And that's my distance function, and it's now a function of y, so d of y squared. Okay, now we can begin differentiating. So I'm just gonna delete, or too used to computers, I'm gonna erase everything else. Okay. So this derivative, I'm gonna differentiate both sides. So the derivative of d squared of y, well, that's going to be the power rule, so it will be 2d of y. And now times d prime of y, right? How much does a small change in y change d, and how much does that change in d change d squared? So this is equal to, let's start with this derivative. I get 2 times the square root of 25 minus 2y squared minus 2. And now I'm going to do my inner derivative, my chain rule once again. So times, so this, of course, is just 25 minus 2y squared to the 1 on 2. So that will be times 1 on 2, 25 minus 2y squared to the negative 1 on 2 times minus 4y, right? The derivative of this term over here. And now I'm going to differentiate this, and that's just plus 2 times y minus 1 times 1, because the coefficient of y is just 1. Sorry for the background noise, y'all. Okay. And the final step is to set this all to 0. And that's, why am I setting this equal to 0? Well, that's the whole reason we're actually differentiating to begin. And it's because if I have a function, when the derivative is 0, it will be either maximized or minimized. So here my function is my distance function. Let's just pretend it was parabola. When the derivative is equal to 0, it will be at a minimum. And so I'm just going to set the derivative equal to 0, find which y value will satisfy that, and that will be the y coordinate of my point. And then I'll be able to find the x coordinate of my point. And then, of course, I'll realize, oh, right, it's symmetrical, there's going to be 2 points there's going to be negatives of each other. Okay. So now we can simplify this up here. And the first step is simplifying this. Well, since I'm setting this all equal to 0, I can divide both sides by 2d of y, right? If I divide both sides by it, it just cancels. So goodbye. And now it's a lot simpler. I have d prime of y is equal to, so I have 2 times a 1 on 2. Those will cancel. So I have minus 4y times the square root of 25 minus 2y squared minus 2 divided by the square root of 25 minus 2y squared, and then plus 2 times y minus 1. Okay, and all of this will be equal to 0. So before I set this equal to 0, I just want to make a common denominator. So I'm going to multiply this term by 25, by the square root of 25 minus 2y squared. So we times 25 minus 2y squared. And now I'll just make this my common base. Square root of 25 minus 2y squared. And all of it is equal to 0. Because it's equal to 0, I multiplied both sides by my denominator, and it cancels. Okay. So now I have d prime of y is equal to, I have minus 4y square root of 25 minus 2y squared plus 8y. And then I have plus square root of 25 minus 2y squared times 2y minus 2. Okay, and this is equal to 0. So now what can I do? I can factorize my square root of 25 minus 2y squared, right? So I will get square root of 25 minus 2y squared times 2y minus 2 minus 4y is equal to minus 8y. And so I have square root of 25 minus 2y squared times minus 2y plus 1, right? So I have 2y minus 4y, that's minus 2y, and then minus 2, that's just low-key lacking. Let's bring out this minus. Actually, no, I'm fine keeping it. 2y plus 2. Minus 2, okay, so that works. Is equal to minus 8y. And what are we going to do next? Well, I'm going to square both sides to get rid of this square root. So I will have 25 minus 2y squared times squaring this term cancels my negative, and it's just the square of this. So 4y squared plus 8y plus 4 is equal to 64y squared. Okay, so now let's expand a bit. Okay. So what do I have? I have 25 minus 2y squared times 4y squared plus 8y plus 4 is equal to 64y squared. Okay, and what can I do now to manipulate? What I'm going to do is I'm going to expand. So I have 25 times 4, that's 100y squared. 25 times 8, that's 200y, well, times 8y. It's 200y, and 25 times 4, that's 100, so plus 100. Minus 2 times 4, that's minus 8y to the 4. Minus 2y squared times 8y, that's minus 16y cubed. And minus 2y squared times 4, that's minus 8y squared. And all of this is equal to 64y squared. Okay, so now I have y squared on both sides. So if I just subtract 64y squared from both sides, this will vanish, and here I'll get 36y squared. Now remember, I have my minus 8y squared, so 36 minus 8, that's just 28y squared. So 28y squared, gotten rid of all of these. Minus 8y to the 4, minus 16y cubed, plus 200y plus 100, I think I have all of them, is equal to 0. Okay, so let's just reorder this, and let's also, all of these are divisible by 4, so let's divide both sides by 4. So I have, divided by 4, I get minus 2y to the 4 minus 4y cubed plus 7y squared plus 50y plus 25 is equal to 0. And now this is an equation for sure to solve. No quadratic formula for us here. So give me a minute. I'll be right back as I learn how to solve this. Okay guys, she's back, and after a few minutes of pondering, I have decided the next step. So how are we going to solve this long equation? Newton's method, of course. I actually learned about it like last week, I think, while reading a book. So this will be my first time actually using it, and yeah, give me a second to wipe down the board and I'll explain it to you guys. So for now, let's just erase everything, including the graphic, the equation, and just focus on solving this equation. All right, I'll be right back. Okay, so I've written down our function over here, and maybe let's just, oh wow, it's a massive drawing. But okay, so this function, it's of a 4th degree, so it will look kind of like this because it's also a is negative, it's principal coefficient, so I don't really know what to do with this. I mean, how many roots does this guy have? Like, I don't know. Let's just assume it looks something like this. Who knows, to be honest. Well, actually, we know this is wrong. We know this is wrong because I know its y-intercept is 25. So we'll just pretend that didn't happen. Draw something weird that looks like this. Of course, we could draw this with a far better precision if we actually did the first derivative and the second derivative, and then it would be way easier. I actually made a video on how to do that, but I'm not going to do that right now because I just don't have the patience. But this makes this kind of ugly. Wow, we're going to make this a really curvy function, but that's impossible. Okay. Say it does something like this. And yeah, let me stop hesitating. So we're looking at Newton's method. Newton's method is a way of finding the roots of a function, and it's an iterative process. So basically, what you do is you find an initial point. Let's call it x1, right? It's your first guess. And you find it's it's not behaving nicely. Let's zoom in over here on this region. Zoom in. And I have something that looks like this, right? So this is my, and then it bends somewhere over here. So this is my x1, let's say. I find its point on the function, and where is its tangent line? Its tangent line will be like here. Actually, this guess might be really good because I can find out its tangent line, and from there I can see where does its tangent line intersect with the x-axis. And for a function that behaves nicely, like it has constant concavity, it will be such that the tangent lines, they will intersect the x-axis on a single side of the root that I'm guessing for, if I've made a good guess. If they overshoot, well, let's hope that doesn't happen. And yeah, the criteria for your guess, of course, is that you're choosing a point where the derivative is not equal to 0. Because obviously if the derivative is equal to 0, your tangent line is flat and it will never intersect your x-axis. Okay, so yeah, the idea is that as my guesses get closer, the tangent lines will start to intersect closer and closer to the root, and I'll see a pattern where it will converge towards the root. So yeah, let's get started with an example. Well, I guess we'll try over here. The problem is I don't really know how this function behaves. I'm already guessing that it's not so clean as a parabola. So we'll see. Apparently this is supposed to work. Okay. So I have my tangent line, y equals mx plus b, or y is equal to, what is this, like y prime times x plus b. So what am I going to do? I need to start with a guess, right? We need to start with an x1. Where do I think that this will intersect? Well, maybe I'll take out the calculator and let's make a few guesses. If y was 1, I'd have -2, -4, so that's -6 plus 7, that's 1, plus 50, plus 25, that's 76. That doesn't look so good. Yeah, we need some bigger terms over here. I think that would be better. Like, what if like y is 2? Maybe it could do some nice things for us. I think y2 might be an overshoot. Let's just say, by the way, I'm just gonna call y x from now on because right now y is the only variable we're dealing with. So yeah, I've made this confusing for us. Y is now equal to z. Okay, so we have z, and z. So when guess 1 is z is equal to 2. So first I'll just find the derivative, right? What is d over dz? If this is f, I guess. Okay, so I will have minus 8z cubed. I'm just going to do the derivative on each term. So minus 2 times 4, that's minus 8z cubed, minus 12z squared, plus 14z, plus 50. That's my derivative. And so when z is equal to 2, I have f of 2, right? So let's just call this f of z. So when z is equal to 2, what will I have? I will have 2 to the 4, so that's 16 times minus 2, so that's minus 32. So 2 to the 3rd, that's 8. 8 times 4, that's also just minus 32. 2 to the squared is just 4 times 7, that's 28. And 50 times 2, that's just 100. And then plus 25. So f of 2 is equal to 2 times minus 32, so that's minus 64, plus 100, so that's 36, plus what do I do? 36 plus 28 plus 25, that's like 53. Plus 53, that's just 69. So I have 69 is equal to, what is now f prime of 2? So this was f prime. So when I substitute 2 into there, wow, this is getting messy. What will I have? Well, I will have, so 2 cubed, that's just 8, minus 8 times 8, that's minus 64. 2 squared, that's 4 times 12, so minus 48. Plus 28 plus 50. So minus 64 minus 48, that's minus 112. So 112 plus 78. So what, like 54? Sorry, minus 54? Whoa. It's way off still. Minus 44. Maybe that's even, wow. Minus 34. The brain cells are sound asleep. But it's okay. We have minus 34. So 69 is equal to minus 34 times 2 plus b. So 69 is equal to minus 68 plus b. So b is equal to 69 plus 68, right? So it's equal to 137. 137. Okay, so I have a tangent line. What is this tangent line? It is y is equal to, where's my Emma? Minus 34? Yeah. Minus 34x plus 137. So, where does this intersect my x-axis? It intersects at, so 0 is equal to minus 34x plus 137. So 137 divided by 34. So when x is equal to 4.029. Okay, so that's where, this tangent line has intersected. Ignore the drawing, I know it's bad. Just say this tangent line has intersected here. And this is my new initial starting point. So this x that I just got is going to be my new guess, and I'm now going to use this as my starting guess. Wow, this is a lot of work. It's okay. So I still have my y prime, that's still good. It's just I'm going to be using different values for it. Hopefully we'll get in a flow and this will become a bit easier. Honestly, I don't even know, maybe I made mistakes with my numbers too. So we'll see. Calculators will need to come out for this though. I'm not about to cube that. Okay, so what do we have? We have y is still equal to y prime x plus b. Also, just ignore the variables at this point. Hopefully you guys understand what I'm talking about. So anyways, f of z is y right now. Wow. And I wrote x here as well. Okay, x is z, y is z. You understand. So f of 4.029 is equal to y prime. So y prime, this is y prime of 4.029 is what I'm going to try and find out. So 4.029 cubed times minus 8 gives minus 523, and then minus 12 times 4.029 squared plus 14 times 4.029 plus 50. Ooh, hopefully this is, I got minus Oh my goodness. Minus 611. 0.61. I don't know about this, guys. Oh my goodness. That's not even the thing. This is f prime of f prime. You guys probably already realized that, but yeah. F prime of 4.029. That's what I was calculating. So now f of 4.029 is equal to, oh wow, it's daunting. 4.029 raised to the 4 times minus 2 minus 4 times 4.029 raised to the 3 plus 7 times 0.29 squared. Plus 50 times 4.029 plus 25. So I have f of it is minus 448.54 approximately. So I have y prime, I have x, so let's just manipulate this to make this faster. So I have b is just equal to y minus y prime of x. So b is just minus 448.54 plus 611.61 times 4.029. So 611.6 times 4.029 minus 448.54. Oh, goodness me. I have b is equal to 2015.6. So I have y is equal to, where's my m? My m is minus 611.61x plus 2015.6. So when this is equal to 0, x is 2015.6 divided by 611.61. Okay, that's not that bad. So my x2, this is my x1. It gave me my x2, so my x3 is 3.2956. Okay. And now we're going to do it again, and we'll see if we start finding a pattern. I probably should not be erasing my previous values. Yeah, I'm going to keep them because I want to see when it starts converging. So that was my guess. Maybe I'll start, all right. So guess one, we had 2, G2, we had 4.029, guess 3, we had 3.2956. We're going for G4. How many iterations should we do? Like, I do not even know. Okay. Now that I have this written down, I can just erase this, make some space. And of course, keep our derivative. There's no point in deleting that, erasing that. Okay. So now, my new starting guess is 3.2956. So once again, I need to find the derivative of that. So f prime of 3.2956. And to do that, I'll just substitute z with, 3.2956 in my little derivative equation here. So 3.2956 cubed times minus 8 minus 12 times 3.2956 squared plus 14 times 2 point, oh my god, have I been writing 2? It's 3. Yeah, I haven't, okay. Plus 14 times 3.2956 plus 50. So what do I have? I get that f prime is equal to minus 320.54. I'm starting to really question the derivative I got before. I don't know. I was messing up what I was plugging in, so I don't know if I was doing the right thing. I guess we'll see. And f of 3.2956. Now I'm going to sub it in there. What does that give? 3.2956 raised to the 4 times minus 2 minus 4 times 3.2956 raised to the 3 plus 7 times 3.2956 squared. Plus 50 times 3.2956 plus 25. I have f is minus 113.28, or 29 we'll say. Okay, so once again, b is just y minus y prime times x. So y prime times x, my x is 3.2956. My y prime is this. So I have minus 320.54 times 3.2956. Is that times my answer? Is that just... Hopefully this is doing the thing I need it to do. Yeah. So, but that's just times -1 because it's negativing it. Plus y, which is, so answer minus 113.29. So what do I have? I have the b is 943.08. And so I have y is equal to m minus 320.54x plus b, 943.08. And so when y is equal to 0, it looks like we're getting some sort of convergence, guys. I have answer, so this divided by 320.54. What is that? Oh no. 320.54, yes. Never mind. Convergence failure. Anyways, I have this, my x4 is 2.59. We're not converging yet, guys. Oh, I guess 4 is 2.59. Okay, let's see how many we do before we call it a day. We'll do more. I wanna approach something. We'll see. Okay, so yeah, let's continue like this. Honestly, I do not know how people did this before calculators. Like, I feel like this is taking a long time with this calculator, which is doing literally 99% of the work. So, yeah, we'll see. My guess is 2.59, so f prime of z. Guys, when I say z, you know I'm actually, what am I doing? F prime of g4. There we go. We have some notation. G4 is just 2.59. So I'll sub it in here. So this cubed times minus 8 minus 12 times 2.59 squared plus 14 times 2.59 plus 50. Okay, so what do I have? I have minus 133.02 and f of g4 Now I'm subbing in up there. What do I get? So I have 2 by 59 raised to the 4 times minus 2 minus 4 times 2.59 cubed plus 7 times, oh wow, 2.59 squared. My nightmare right now is that my calculator tells me there was a typing error. Plus 50 times 2.59 plus 25. We have F is equal to 41.96. 41.90. Oh goodness. That does not give me hope either. We'll see. So, why do I keep on erasing this part? B is equal to y minus y prime x. So that is, B is equal to 41.96 minus, so minus and minus we'll just do plus, it's 133.02. 133.02 times my x, which is my guess, which is G4, so times 2.59. Syntax error. 133.02 times 2.59. Okay, so that's plus 344.5. So 344.5 plus 41.96. Okay, so I have B is equal to 386.48. And so y is equal to m, so minus 133.02 x plus b plus 386.48. Sorry guys, I know my voice is getting kind of slurred, like I think I'm just tired. Anyways, we're setting this to 0. And so now I find what x will be. So subtracting 386.48 from both sides, dividing by 133.02. I have x is equal to 2.9. Oh guys, I'm confused now. Oh, wow. That done just ruined me. X is equal to 2.9. I just said x is 2.59. And moving backward. Okay, it's okay. Shall we go again? Okay. We'll go to 7 guesses, I think. At that point, if it's not converging, we'll table it. G5 is 2.9. Did I type this wrong, or is it just genuinely? I feel like no, I don't know what's wrong with this, honestly. Whatever. 386.48 divided by 133.02. Yeah, it's still 2.9. Okay, maybe I can be a bit more specific with this. It's 2.91. Okay, and now let's go on to our next convergence. Okay. So we have f prime of guess 5 is equal to, subbing in x over here, so I'm going to cube that, times minus 8 minus 12 times 2.91 squared plus 14 times 2.91 plus 50. Okay, so f prime is minus 207.1. Maybe I'll say 0.09. Let's give ourselves a chance here. F of G5 is, so subbing my 2.91 up here, so I have 2.91 raised to the 4 times minus 2 minus 4 times 2.91 cubed. 2.91 cubed plus 7 times 2.91 squared plus 50 times 2.91 plus 25. So I have f is equal to minus 12.21. Okay, my f's are getting smaller and smaller. Anyway, so now b is going to be minus 12.21 minus my derivative times x itself. So 207.09 plus, times x, which is 2.91. That's this over here. So minus 12.21. So I have b is 590.42. And so I have y is equal to minus 207.09x plus 590.42. And so when y is equal to 0, my x-intercept, what do I have? I have divided by 207.09. I have 2.85. X equals 2.85. Okay. So guess 6. We have one more, guys, after this. We have 2.85. Honestly, we're getting faster. We're getting faster at it. So, okay. Using my guess 6, 2.85, I'm going to do the derivative again. So f prime of g6 is, so this cubed times minus 8 minus 12 times 2.85 squared plus 14 times 2.85 plus 50. It gives me minus 192.97. And then f of g6 is subbing over here. So I have 2.85 raised to the 4 times minus 2 minus 4 times 2.85 cubed plus 7 times 2.85 squared plus 50 times 2.85 plus 25. Whoa, did I type this wrong? I have f is equal to minus 0.189. Hopefully this is just meaning we're converging. Yeah. Okay. Anyways. So, I have my b is, well, you guys know the drill. Use this formula, find b. So, my f prime, it's minus 192.97 times, well, why am I negativing it? It's a minus times a minus cancels. 192.97 times 2.85 minus 0.189. So I have that b is equal to 549.78. And so I have y is equal to m, so minus 192.97x plus b, so plus 549.78. What this means is that, well, yeah, because f is becoming so small, I'm essentially dividing b, which is essentially just y prime of x times x, by y prime. So it's approaching x is it's approaching x, whatever x is. The margins between my x's are getting smaller, I think. So divided by 192.97, I have x is equal to 2.849. Guys, I honestly don't know at this point. I'm gonna go check the Chromebook. See if we've converged to anything close. G7, for the record, is 2.849. I'll be back in a second. Guys, after much anticipation, this is actually successful. Well, no, it's not successful. We did converge to a root of this large equation. However, it was not the correct root, right? Remember the solutions to this, the different values of y? We're looking for the value of y that minimizes the distance. On our previous ellipse, x squared plus 2y squared equals 25. We landed on a y value of several, and it wasn't the correct one. The Newton's method was correct though. So what we would do differently is start with a better initial guess, maybe sketch out the function, find out what it kind of looks like in general, and then we can maybe make a better guess. But yeah, the correct root I think was like 1, or was it like 1.51 or 0.51? Anyways, you guys can look it up. This is one of the, honestly, we can be proud. Newton's method worked, it just, bad guess, bad initial guess. But if we take another guess, you might land on the correct y value. Once you find that y value, sub it back into your original equation, and you'll be able to find different x values. Yeah, and those will be your points. So thank you for watching, guys, and have a good sleep at this point.